reason for the seasons. Why are the North and South Poles the coldest places on the Earth? Well, please consider the following. Let's say that this heat lamp is like the sun, because it's hot. And let's say that this globe is like the Earth, because it looks like the Earth. Anyway, we've mounted thermometers on the Earth like this. See? Now, the one at the equator is just about off the scale, and the one at the South Pole is right around the room temperature mark. And the ones in between are somewhere in between. That's because the heat is hitting the one at the equator almost straight on, whereas at the poles, it's just barely grazing by. And then somewhere in between, well, it's somewhere in between. You see, it's not that the equator is closer to the heat, it's that the heat is hitting it more straight on. See, if the Earth were sitting like this, then this thermometer would be the hottest, and this one would be the coldest. Anyway, that's why the very warmest places on the Earth are right around the equator, tropical rainforests and jungles. And the very coldest places are at the poles, because they're the ones that the energy from the heat lamp just barely grazes by. I mean, the energy from the sun. Well, anyway, thank you for joining me.
Do you notice, though, that the axis about which the Earth turns is not straight up and down. It's tilted to one side, at an angle of 23.5 degrees from the perpendicular. This has a lot to do with why we have different seasons, as we shall see.
Let's say that this plastic globe of science is like the Earth, and we have two solar panels mounted on it. Now, solar panels convert light directly into electricity. So right now, these two panels are making enough electricity to run these two little motors. Now, right now, both motors are going about the same speed. Now, notice that we have one panel in the northern half of the Earth, the northern hemisphere, and one panel in the southern half of the Earth, the southern hemisphere. They're both receiving about the same amount of light. But let's say it's summer here at Nye Laboratories in the northern half of the Earth, the northern hemisphere. That means that the Earth would be tipped toward the sun about like... Now look, the motor in the southern hemisphere is just barely moving, and the motor in the northern hemisphere is spinning like crazy. Now let's say it's 6 months later, and the Earth has gone around the sun so that its axis is tipped this way. Now look, it's reversed. The one in the south is going wild, and the one in the north is slowed way down. See, what that means is that this panel in the southern hemisphere is receiving more light, more energy from the sun than the one in the northern hemisphere. It's just like the Earth's seasons, right here with the solar panel plastic globe of science.
Using a flashlight, you can see for yourself that direct rays are concentrated on a smaller area than slanted rays. This is why direct rays produce more heat.
Hey yo, 5th grade, it's time to rhyme it. These are the factors that affect the climate. Look it up on a map and don't give me attitude. Degrees to the north and south we call latitude. In the middle, sun really beats down. That's why it stays warm all year round. As you move away, higher latitudes are colder. Climate zones tropical, temperate, polar. So you know that the equator's hot, but just ask the penguins, the poles are not. Equator's hot, but the poles are not. I said equator's hot, but the poles are not.